So we're about to test out these new braces here and here. We have 5 bolts tying it into the Z-axis way on this side and 5 bolts on the other side as well. And then there are a total of 6 bolts tying it both into this bottom C channel and the top, or the Y way. So with these modifications combined with this stiffener, we're going to go ahead and rerun this. We know that last time we were 5 thou off this way, and we know that when we were digging into it this way, we saw a deflection in the video. So I'm going to go ahead and put the old video on the left and the new run on the right with a line on each spindle to see if there was a difference or an improvement. And we're going to go ahead and run this. This is the exact same bit, the exact same piece of metal, as you can see. We're just going in on this side. We got the same amount of overhang out, roughly as last time. Same jaw, same pretty much RPM, same everything really. So we'll do an apples to apples here and see if these combined with this help improve it. Alright, so on the left are before we've added the stiffeners, and on the right is after we've added the stiffeners. There'll be 2 white lines top left of the spindle, and those will not move. They're just there as reference for your eyeball to see how much the spindle is deflecting. On the leftmost image, I'm putting a red line to indicate where the base is. That's not going to move as well. You'll see why we need that later on. But as you can see, both deflect a little bit. I made the white line so that the leftmost portion of the white line lines up with the leftmost portion of the spindle. So as you can see, a lot less deflection, probably a third less deflection after the improvements on the right side. And on the left side, notice how every time we enter the material, it deflects, and then it kind of starts coming back to normal, and then fully back to normal. But now, as we get into the meat of it, and as it starts putting a load the other way, we see the one on the left deflecting back to the left. So line goes to the left, but then it also goes back to the right. Whereas on the one on the right, we don't see that. Or at least if we do, it is so minuscule. It's really hard for me to pick up with the naked eye. So big improvement, right? So here shortly, we're going to go slow motion, and I want you to pay attention. Because what I think is happening is, I think the one on the left, I think we're getting past yielding, the yield point of aluminum. And at that point, we're getting permanent deflection. Alright, so here we go, slow motion. So we're entering the material, line moves to the left. Now, at this point, we should go back to neutral. And we see that on the right, but on the left, look, it went the other way. So there's some major deflection going on here now that it's a U shape instead of a flat shape. We're seeing it. We see the spindle move to the right, and now we're seeing it move to the left because of the cutting forces. Now, because we are conventional milling, so we're turning clockwise as we go into the material. So yeah, just pay close attention, see the differences on these slow motions, and you can see much, much less deflection, and permanent deflection even. Here we have the before. Both lines, the left side of that line lines up with the left side of the spindle, but now the one in behind it, that one shows the permanent deformation that happened. So pretty cool stuff. Before improvements, after improvements. Well, hopefully it's an improvement. Well, let's see if there's any difference in our readings. So this is before. So 0.996995. I'd say, heck, we may have gotten even a little stiffer in the y-axis. pretty darn close. Hard to say. Trying to think if there's a way we could judge the depth on this accurately, you know, to get an idea of how, whether or not we met our tolerance here. Okay, so this is before stiffening, after stiffening. Best way I could come up with measuring it is to place this flat bar here across the opening and measure between, to try to get an idea of how much we stiffened up that axis. So it looks like 819. And then 825. So our bracing managed to improve the x-axis by 6 thou. That's pretty awesome. Pretty pumped about that. Hey, if you like what you're seeing here in the background, just let me know and I can get a build video put together for this. Planning on coming out with some plans showing hole location, depth, things like that, maybe a 3D model, and I should have that by the end of the week. This is really starting to get exciting. We are putting very little money into this thing, and we're getting some excellent results out of it. Stay tuned for some more testing where we get down to tolerances, and thanks for watching.